Hi, in this video I'm going to show you how I tested this 100 watt LED I got from Amazon for $10. As you can see, I already attached it to the old Intel CPU heatsink. It has fan and 4-wire connector. And before I attached the LED, I applied some thermal paste to the back of it. So basically it's between the heatsink and the LED. Then I soldered some thick wires and I wrapped them around with Kapton tape so they don't short on the aluminum heatsink. To hold LED in place, I used these small sheet metal screws and attached it directly to heatsink fins. For powering LED, I used these 14 gauge speaker wires I got in the auto parts store. In order to power this computer fan, you're going to need to connect it to 12-volt power supply. There are 4-wire connectors, so you're basically gonna use black wire for negative and yellow wire for positive. It will work anywhere from 5 to 12 volts. As a power source for the fan, I used my variable benchtop power supply. I was curious how hot heatsink will get, so I used this digital temperature meter with K-type probe. These are TM902C meters from China. I got them about $5 for each, so they take 9-volt battery and they're actually pretty accurate. So I just basically shoved it between the fins and used a little bit of Kapton tape to hold it in place. In reality, you don't have to use Kapton tape, it can get pretty expensive. But I already had a roll which came with my 3D printer, so I decided to use it. Advantage of Kapton tape, it can withstand pretty high temperature. But in our case, you can use probably regular Scotch tape or electric tape. It should be just fine. Next, I am going to hook up this DC-DC power converter. This one's pretty beefy. So first I'm gonna connect the output. So I'm gonna connect a piece of wire to the negative terminal. Then I'm gonna take, you can see, hopefully, positive lead from the LED and hook it up to positive terminal. Then I'm gonna use my multimeter to measure the current. So the current is gonna go from positive wire into the LED, then it's gonna come back and it will go into my multimeter and then out to the negative wire here. I am not gonna connect this right now, so I'll set it up for amps and change screen to amps DC. Hopefully you can see the screen. Okay, good. Now I also need to measure output voltage, so I'm going to use my second multimeter. Set it to DC volts, and I'm going to hook it up with some jumper cable. Into output here. So I'll just use those alligator clips here and here. Okay, so now we're setting up input. So input's gonna be coming from 12-volt power supply, like this one. This one can output up to 30 amps.
So one more thing. If you can see this, I have this another voltmeter here. So I'm just going to attach it for fun to the input, just to make sure we're getting 12 volts. And it's becoming messy at this point. Okay, so we're ready to plug in. So I'm going to plug this in and we'll see what happens. Okay, and as you can see, we're getting 35 volts on the output, which is perfect for this LED. It's actually maximum range. And next thing I'm going to do is I'm going to connect the output, and it's gonna get really bright now. Okay, as you can see, I'm getting about, you can see it, 1.3 amps. 1.3 amps right now, which is not too good. Should have more. It's pretty bright. This power supply, this DC converter kind of sucks. It has a separate adjustment for the current and voltage. So voltage I'm already at max, I don't want to go above that. The current is actually also at max according to this. I can keep turning, but it's nothing happens if I turn this. Oh, it's not increasing. But I found if I move the voltage up and down, sometimes it changes the amplitudes. So let's see how low can we go. As far as temperature, we're getting about 27 degrees Celsius right now, 28. Oh, that's because I forgot to turn on the AC, I mean the fan. So let's turn the fan on. Let's cool it down a little bit. Yeah, let's see how low can we go. So right now I'm getting 28 volts, LED is still on. Let's go down to 26 and a half and 25 and a half. That's it, at 25 and a half it starts to blink and strobe, so let's go higher. Let's go up. And temperature went down to 21. Alright, we're getting 28 volts, half an amp, 30 volts now. Okay, almost an amp. Yes, now we're getting an amp at 31 volts. I'm getting 1 amp output. Let's see, 32 volts, we're getting still 1.1. And 33 volts. And LED is blinking. I really need the current driver for this. Oops. So let's go higher. Let's see how high can we go. 34 volts. And 35. 1.4 amps. This is low. Let's go higher. Let's go to 36 volts. Let's go to 37 volts. Almost 2 amps. Let's go to 38 volts. More. 39 59. We had 2 amps right now. See? 2 amps. Temperature's holding, so looks like you can drive these at higher voltages as long as the amps are pretty high. But let's adjust our amperage down. Let's move it to... Oh, nothing changes when I move it. This thing is broken. Oh, here we go. Changed a little bit. Let's do 40. 40. Yep. 40 volts, 2.2 amps. So let's take a look what kind of amperage we're getting from power supply into this thing. So we know output is 1.4 amps, 35 volts. So let's disconnect this. And we are getting 5 point, let's see this, we're getting 4.5 amps of incoming current at 35 volts of outcoming, and I believe it was 1.5 amps current on the output. So that is a lot of current, and if you hook it up to the battery, you have to make sure your battery can handle the current.